Now let's extend our problem to the second list. So here the first element we get is 3. Of course, we don't have any problem to insert 3 here. Second element, which is supposed to be placed here at location 1 and value is 1. Yes, of course, there is an objection raised because 1 cannot be a child of 3, and to make sure that this conflict is solved by swapping these two positions. So 1 comes on the location 1, 0, and 3 gets to location 1. Okay, the next one we get a value which is supposed to be at position 2 and the value is 5. Any problem? I don't think, because 5 is greater than 1, so 5 being a child of 1 is no issue at all. The next position is at 3 and the value is 7. So 3 is parent, 7 is child. So definitely there won't be any problem. And when it comes to next value, it has to be written here at location 4 and the value is 11. Any conflict? No. 3 is the parent, 11 is the child. Definitely there should not be any problem in the heap property constraint. And the next value we get is 9, and that has to be at location 5 and value is 9, and 5 is the parent, 9 is the child. Definitely there won't be any conflict again. So that's a heap we have, and if you look at it at level 1, level 0 we have 1, at level 2 we have 3 and 5 which are greater than 1, definitely, therefore no issue. And children of 3 are 7 and 11 which are greater than 3, no issue. Child of 5 is 9, so greater than 5, no issue. So at every position, if you look at it, child has a value smaller than the parent, so no issue. So we have a minimum heap. Now in creating this minimum heap, there was an issue presented. So at that time we just swapped these two values. The earlier value was 3 here and 1 here, which were swapped. Okay, let's see what can go wrong if we use the third set. The sequence is changed, only the values are same, the sequence has changed. So 7 comes to the first place, and then second place occupied by 11. So 7 is a parent, 11 is a child, no issue. Then third position, that is position 2 occupied by 9, 7 parent, 9 child, no issue. Then the next value we get should be placed at position 3, whose value is 1. 1 is a child, 11 is the parent, so this is not admissible. Therefore, shift 1 a level up by swapping, and after swapping, this becomes 1 and this becomes 11. So this problem is solved, but 1 as a child and 7 as a parent, again there is a problem. Therefore, there is another swap required. And finally, what we get is we get a 1 here and a 7 here, and we had a 11 here. So 1 here, 7 here, 9 here, 11 here. After 2 swaps while inserting, we had this done. So after inserting 1, the problem is solved. Okay, then so these were the disturbances created because of inserting 1. Now let me insert 3. 3 has to be placed at location 4, and 3 is here. Its parent is 7, therefore not allowed. So swap 3 and 7 positions. So 3 comes here, 7 comes here. After swapping, make sure that 3 has reached the correct place. So find the parent of 3. It is 1, which is definitely less than 3. Hence, it is in its right place. So just one swap will shift 3 to its correct position. So next thing is 5. 5 has to come here, which is at location 5. And when you see 5 is a child of 9, which is not allowed in min heap. Therefore, 5 and 9 are to be swapped. So 5 comes here, 9 comes here. Now check whether 5 is in right place. Yeah, 5 is in right place because 5 is child of 1. So no issue. And 5 is parent of 9. No issue. So now again, just for verification, level 1 has got a smallest value, which is 1. And its children 3 and 5 are bigger than that, no issue. The children of 3 are 11 and 7, definitely no issue. Child of 5 is 9, so no issue. Now, if you look at the 3 heaps we have built, so depending on the order in which the elements are inserted, the tree may look different as far as the values are concerned, but the structure is going to remain the same. So if 0, 1, 2, 3, 4, 5 are the nodes being used, sixth node is empty because there are only 6 elements here. We are starting from index 0, so index 6 is missing. And if the 7th node comes in, then it has to be in this position 6, and 8th one has to take the next one, and so on. So it's filled layer wise. Yeah, that's a condition of the heap. Second thing, every node value should be greater than its parent's node value. Okay, that's another thing. Then you can find many different possible heaps. So one thing is common. What is common in all is the structure, how it looks. So you can just see the structure. And the second thing is the root value. Whatever be the structure, on the root we have one only. So that is our minimum of the list is always at the root. So that's minimum heap. So the whole process, if you reverse it, then it becomes maximum heap. So no big deal in creating a maximum heap, because if you are working for profit, you will need to work with max heap. So just the conditions are reversed. The position issue is same, only issue of relation between parent and child has to be reversed. So that's only thing. Rest all are the same. So that's how the insertion is done in the heap tree, whether it's min heap or max heap. So whenever insertion is done, so the first thing is the appropriate position is to be selected for inserting the node, and then once you insert the node, insert the value, and then verify whether the min heap or heap property is satisfied or not. If it is not satisfied, then appropriate action like swapping has to be done to move the inserted value to its correct position. So till then, you just keep moving it upwards, upwards, upwards as we did here. Now, as an example, if you think that 0 gets added to this new number, so when a 0 gets added to this list, then what would happen is, of course, 0 is added here, and because 0 cannot be here, then we need to update, swap this. 0 comes here, 5 comes here, and 0 cannot be here, therefore move 0 upwards. 0 comes here. Yeah, that's the correct place. Now in this, if you make a 0 here, again shift 0 upwards, not a right place, shift 0 upwards. So shifting 0 upwards means swapping the values, swap these two values. So in that case, what would happen is 5 is swapped with 0, and these are not in right place, therefore 0 gets swapped with 1. So we have this. And in case of this one, if we try to add a 0, then one swap is required here, one swap is required here. So we have the new one looking like 0 here, 1 here, 5 here. Okay, then what would happen if you add new element? Definitely the new element is to be added here, because that has to be that's the next available option. So we need to add this and move this way as we keep adding. So that's how insertions are done.